In this presentation, we will learn how to insert a new node in between the other nodes in a circular singly linked list. So let's get started. Let us suppose this is the initial state of the circular singly linked list. You can see that there are 3 nodes in the list and tail pointer is pointing to the last node of this list. Currently, we have a position variable which is holding this value 2. Our target is to add a new node after position 2, that is after this node, because position is given to us, this is 2. That means our target is to add a new node after position 2, that is after this position, we want to add a new node. Let us suppose we want to insert this new node after this position 2. For this purpose, of course, we need a pointer because we need to do the traversal. Here, we need a pointer which must point to this particular node so that we can add this node after this node, right? For this, we will keep a pointer p, and currently it must point to this node. And for this purpose, I have to write this line of code, that is struct node star p, and then after this, I have to write this line of code, that is p is equal to tail next. Tail is currently pointing to the last node, and tail next means 1000 address. So we want to store this address within pointer p. After this, we will use this while loop for traversal. Here, inside this while loop, you can check this condition, pos greater than 1. Instead of using position variable, I am using pos variable. Okay, both are one and the same. While pos greater than 1, p is equal to p next, pos minus minus. Okay, so we'll decrement the pos by 1 every time. Here currently pos is containing 2. So here this pointer will move 1 step forward. That means it will stop at this point. That's what we want. That is why I'm keeping this code. Okay, so this pointer, as you can see, is now pointing to the second node of this list. After this, we will update the next part of this node so that it can point to this node, and that is why I'm keeping this line of code, that is new p next is equal to p next. You can see over here that the next part of this node is now updated. After this, we will update the next part of this node so that it can point to this node. For this purpose, we will put this line of code, that is p next is equal to new p. This is all what we need. But let us suppose that position is 3 instead of 2. That means we want to add a new node after this position. Now it is clear to you that we want to add a new node at the end of the list, right? We will keep the same code, but we will make some changes to it. We will actually replace this piece of code. So this piece of code can be replaced by this piece of code. So we will replace that code by this code, okay? If p is equal to tail, that means if pointer p is pointing to this node, then we will do this procedure, else we will do the usual procedure, right? Here you can see that there are 3 lines of code written. First, we know that after this while loop, p will point to this node, right? This means after this, we will check this condition. Is p equal to tail? We know that p is equal to tail, right? That means p is pointing to the last node of this list. So we will update the next part of this node so that it can point to this node. Then we will update the next part of this particular node so that it can point to this node. And finally, we have to update our tail pointer so that it can point to this node. And that's all what we need. Now let me tell you, there is some redundancy in this code. Instead of writing new p next equal to tail next, you can also write new p next equal to p next, because p and tail were initially pointing to the same node. Isn't that so? So instead of writing new p next equal to tail next, you can also write new p next equal to p next. And then again here, instead of writing tail next equal to new p, you can also write p next equal to new p. Both are one and the same. That means link updation is same no matter what node you are considering. But this line of code must be added in case when p is equal to tail. So if p is pointing to the last node of the list, then tail pointer must be updated in that case, else it is not required. Okay. So better code is, we will keep these 2 lines of code outside and then we will check this condition. If p is equal to tail, then tail must be updated. That's it. Let's just see whether our code is working fine or not. First, we will evaluate this line of code, that is new p next equal to p next. That means we will update the next part of this node so that it can point to this node. Then we will update the next part of this node so that it can point to this node. And finally, we will check this condition. Is p equal to tail? You can see over here that p is equal to tail. So we have to update our tail pointer so that it can point to this node. And that's it. So you can see over here, this is the resultant linked list so obtained. When we have position is equal to 2, that means this new node has been added between these 2 nodes, right? And obviously the time complexity is big O of n because traversal is involved, right? Now let me just show the complete code in code blocks. You can see over here, this is the complete code. Struct node is declared, add to empty function is there, add at end function is also there, and we have this add after pos function. which is used to add a node after a given position. Here we are passing tail to it, data as well as pos, that is position. Here, this is the similar code we have seen already. Obviously here, we are allocating memory for the new node as well. Apart from this, everything is similar. There is a print function which is used to print all the elements of the linked list. We are first calling add to empty function, then we are calling add at end function twice so that we would be able to add these two nodes after this node. And then I call this print function to print the current elements of the list. Then I call add after pos function so that I would be able to add a new node after certain position. That is basically the data of that node is 66. And if we try to print all the elements of this linked list, then it would be like 34, 45, 66 and 6 because here the position is 2. Now let me just execute this code. You can see over here the output of this program is 34, 45, 66, 6. That means after position 2, the node has been added, right? Now, let me change this position to 3 and let's just execute this code. You can see over here a new node is added after this node, right? Okay friends, this is it for now. Thank you for watching this presentation.